All right, we're on 1.7 special pairs of oblique angles. So we talked about oblique angles are all those that don't add up to be right angles aren't equal to right angles and aren't equal to straight angles. Everything else is an oblique angle. We have special pairs of oblique angles. The first one we'll talk about are complementary angles. All right, so complementary angles add up to be a right angle. So if I'm looking at this first figure, I've got angle AOB and I've got angle BOC. And I left the part that, compared to the figure that you're looking at in your book, it's on page 13, there's one little difference. The one in the book has this little box right here. I know we've talked about that before, that we know that if it has that box in there, that it is a right angle, it's 90 degrees. But if it doesn't have that box, I cannot say that this is a right angle. It looks like a right angle, and I could put a protractor on it and measure it to confirm it's a right angle. But to the naked eye, a right angle is exactly 90 degrees. It's not 89.9 degrees. And to my eyes, I can't tell the difference between a 90 degree angle and an 89.9 degree angle. So I need to make sure that it has that little box. That's what tells me, or you're telling me, this is a right angle. All right, so if you're trying to make a right angle, put the little box there. Make sure you've marked it clearly that this is a right angle. Even if your drawing is bad, your box supersedes your bad drawing. So maybe you actually drew an 87 degree angle, maybe you got in a hurry and you did something like this. But when you put this box there, that tells me that your intent was that was a right angle, right? Hopefully we can do better than that, but that's what tells me it's a right angle, not a really good drawing. All right, so complementary angles are two oblique angles that when added together, they add up to be 90 degrees. So I have angle A to O to B. I made sure to put my vertex in the center. And I have angle B O C. When I add angle AOB, whatever this one is, to whatever BOC is, I know they add together to equal a right angle. So these two are complements of each other. They're complementary to each other. They add up to 90. Next we have supplementary. All right, complementary angles, we'll just say the sum is a right angle. Supplementary angles. So here I've got a straight line A to C and another straight line B and O. And so I know from A to C, I know that's a straight angle. It has to be because it's a straight from here to here is a straight angle. All right. So I have angle A to O to B. And over here, I have angle B to O to C. When I add this angle plus that angle, they add up to be a straight angle. So the sum is a straight angle. All right, so complementary angles add up to be 90 degrees or a right angle. Supplementary angles add up to be 180 degrees or a straight angle. All right, now to go to my point a minute ago about this little box. BOD looks like it's probably a right angle. AOC looks like it's probably a right angle, but they're not marked, so I can't say that those are right angles. I can't say that this one and this one are right angles. Because I can't say that, this part's going to use a key word whenever it's explaining this particular part. If, that's the difference. If it was marked as a right angle, I wouldn't have to use that word. But if angle AOC is a right angle, if angle AOC is a right angle, then angle BOC. So if AOC is a right angle, then angle BOC is a complement to angle AOB. So what they're saying is if angle AOC is a right angle, then angle BOC, or angle 1, is a complement to angle 2, which is BOA, or AOB. All right. And if angle 1, if AOC is a right angle, this is similarly, if that's true, then angle 1 would be the complement of angle 2, and also it'd be the complement to angle 3 if BOD is a right angle. All right, so that's why that little box means so much. If this had a box here, that tells me that that's a right angle. I wouldn't have to put the word if there. I would say angle AOC is or angle BOC is a complement to AOB, because that little box tells me that it's right angle. All right, and that's super important. I know it's easy to overlook. It looks like it's probably 90 degrees or a right angle, but we really need to know. Lastly, we'll talk about vertical angles. Vertical angles really are just talking about location of two angles in relation to each other. When two straight lines intersect, so you have angle or line C to D and line A to B, and they intersect at point O. So those are two straight lines that intersect. So when two straight lines intersect, the two angles not adjacent, we talked about adjacent angles would be like angle DOA is adjacent to AOC because they share a common side and a vertex. So if they're not adjacent, then they're vertical to each other. So what they're saying is angle, this one right here, angle AOC is vertical to angle BOD. Alright, so that's this angle is vertical to this angle. This angle BOC is also vertical to AOB because they're straight across the road. Alright, so if they're not, when it's just four angles by two intersecting lines, the angles are either going to be vertical to each other or adjacent to each other. Alright, so you have exercises 1.7, got about 13 questions there. Oh, nope, you got about 23 questions there to work on, just for some extra practice and get you more familiar with it. That's it for this one. We'll come back on 1.8, measuring angles.